Hello, everyone, and welcome to another wonderful day of chemistry. So today we're going to be talking about how we can determine whether or not a reaction wants to occur or not. So this is called spontaneity. And this is really going to be the focus of the next chapter. And I want to kind of give you some guidance of, as we go into chapter 13, what we should be looking for. And again, this entire chapter is going to end up focusing in on this idea of stability and favorability. So far, the only metric we've had to determine whether or not a reactant or product is favorable is enthalpy. And it is a decent metric. It tells us how strong bonds are, the strength of IMFs, what way the system wants to go. However, it doesn't encapsulate everything. A good example of this is if we look at something like melting of water. So I have a nice clump of ice, I melt it. The enthalpy of fusion is uphill. It takes about 6 kilojoules of energy per mole of water in order to make this reaction happen. And that in and of itself tells us a lot, because we know that this reaction is enthalpically uphill. It means this reaction doesn't want to happen. However, we know that the reaction does happen. And that's really going to be this conundrum that we're going to be focusing on most of this chapter. How can I go ahead and determine whether or not a reaction occurs or doesn't? And it turns out enthalpy does play a major role in this story. However, we do need to encapsulate some other features. And one of the biggest ways we're going to be doing this and going from enthalpy to true favorability is going to be by bringing in entropy. So entropy is this idea that chemicals want to essentially spread out. Ice is very highly ordered. Water, not so much. And it turns out molecules like to spread out, or they like to disperse, and colloquially entropy is regarded as a form of disorder, because that really does encapsulate what happens when things spread out. If your clothes are in your closet, they're highly ordered, they're localized. If they spread out across your floor, they're very dispersed and very disordered. And this is really what we're looking at with entropy. However, we have to encapsulate this double feature. You like to have your clothes ordered in your closet, but you also are lazy and you want to let them spread out on the floor. Gibbs free energy is going to give us a single metric that predicts which one is most likely to occur at any given point in time. And as you might anticipate, a lot of different features can control the Gibbs free energy. And we're going to use temperatures and concentrations and other metrics to help decide which way a reaction tends to go. Next time, we're going to go ahead and dive in a little bit more detail and focus on this idea of entropy. Until then, take care.